I would now like to look at some examples of proving trig identities. The first example I'll look at is prove that sine of x times cotangent of x plus tangent of x equals secant of x. One of my guidelines told me to start with the more complicated side. In this example, it looks like the left-hand side is the more complicated side, so I'll choose this side to start. Now, having chosen this left-hand side, my ultimate goal is to simplify the side so that it's equal secant of x. I cannot and do not want to move terms over the equal sign, so I will start with the left-hand side and I will stay on this side. Another guideline said that if there were operations to be performed, perform those. We understand here that the parentheses and the sign of x on the outside is indicating this sign of x needs to be distributed to the two inside terms. And so that's how I will start. Okay, I will start by distributing. On here, you can think of trig functions as variables. In other words, I know that I really can't multiply variables together unless they're the same variables. Same thing here. When I multiply sine of x times cotangent of x, I just leave it as a product. Sine of x multiplied by cotangent of x plus, and then sine of x multiplied by tangent of x. One of my other guidelines had initially said if you have trig functions that are not sines and cosines, change them to sines and cosines. I could have done that to start, but it actually is easier to wait until you're at this point to change things to sines and cosines. The first term is already a sine, so I'll leave that alone. The second term is cotangent of x. I know an identity that has to do with cotangent involving sines and cosines. The identity is the cosine of x over the sine of x is the same thing as cotangent. For the second group, I'll leave the sine of x alone, and then tangent of x, I know an identity that says it's sine of x over cosine of x. The identities need to come to you quickly. When you're proving trig identities, you don't need to worry about trying to remember your identities. You need to already know them. From this point, we see that we have created fractions. Let me put the sine of x over 1 so that we have those as fractions as well. One of the other guidelines said to do any kind of operations that you had. Well, at this point, I'm multiplying fractions. On the first fraction, I have a numerator that cancels with its denominator. And so in this case, I'm left with just cosine of x. On the second fraction, I don't have that situation where I can cancel. But I can multiply the numerators and the denominators. Sine of x times sine of x is sine squared of x. And then 1 times cosine of x is just cosine of x. Now, once I get to this point, it's sort of the same situation as before. I still have fractions. I'll put this over 1. But the difference is now I'm adding fractions. To add fractions, I need a least common denominator. Okay, look at the denominators. I have a 1 and a cosine of x, so that would be cosine of x. My first fraction, to be able to get the common denominator, I need to multiply it by cosine of x over cosine of x. The second fraction already has what I need, so I'm going to leave it alone. Okay. Multiplying those two first fractions together, I have cosine squared of x over cosine of x. The second fraction I'm going to leave alone. And then once I get to this point, I notice that my denominator is the same in both fractions. The rule for adding fractions is you add the numerators. So I'll have cosine squared of x plus sine squared of x, and then you keep the denominator. The denominator is just 1 cosine of x. Now, from this point, I've combined all the like terms that I can. I've combined my fractions together. In the numerator, I notice that I have something that reminds me of a Pythagorean identity involving trig functions. The one that it should remind me of is that sine squared of x plus cosine squared of x equals 1. It doesn't make a difference that the sine and the cosine squared functions are out of order. That whole numerator can be reduced to 1. So we'll have 1 over cosine of x. Finally, 1 over cosine of x is a reciprocal function for secant of x. Secant of x is our desired result. We have proven this identity. If we scroll back up to the top of the page and we look at our original identity, we were trying to prove that the left-hand side equaled secant of x, and we have done this. This concludes this example of proving trig identities.